In this video, we'll be exploring the concept of Maclaurin series. If you are new to this channel, please take this time out to subscribe to the channel and hit that notification bell to be notified whenever we post new videos. Alright, so we want to look at the Maclaurin series. Now, according to this piece of information right here, the Maclaurin series expansion is an approximation to a function using the sum of the derivatives of the function evaluated at 0. So the Maclaurin series is a special case of the Taylor series, alright? And hopefully in the future I'll be creating a video demonstrating what the Taylor series is all about, alright? So this is the Maclaurin series formula. So according to this formula, f of x is equal to f of 0. So when you sub 0 into the f of x function over 0 factorial plus x times the first differential when you sub 0 into the first differential over 1 factorial plus x squared times the second derivative when you sub 0 into the second derivative over 2 factorial. And we can continue this thing, alright? So we can make many iterations. So we can carry out many iterations as it relates to the Maclaurin series, alright? Maclaurin series enables us to rewrite many functions as polynomials using the formula, alright? So that's what we want to do. So it enables us to rewrite many functions as polynomials, and we'll look at that. So using this formula, using the Maclaurin series formula, we can rewrite many functions, alright, as polynomials. So I'll demonstrate that. Now let's look at how to write Maclaurin series expansion for the function f of x is equal to e to the power of x, alright. So how do we go about this thing? Now, some of the things that we want to find f of 0. We also want to obtain the result that we'll get after we substitute 0 in the first differential of f of x. And we'll also want to find the result that we'll get when we substitute 0 into the second differential of f of x, alright? If we're going to do 3 iterations. Now, if we're going to do more iterations, then you want to find the result that you'll obtain after you sub 0 into the third differential of f of x and so on and so forth. So you can continue this thing, many more iterations, alright? But we are going to stop at 3 iterations. So we are going to just look at this part right here so we can complete this video in a timely manner. Alright, so what is f of 0? F of 0, what would you get if you replace x with 0? Alright, we'll obtain e to the power of 0. Anything raised to the power of 0 is 1. Alright, now the second thing that we want to find is what? What do you get if you substitute 0 into the first differential of f of x? Alright, so we need to find the first differential of f of x first. Alright, if you differentiate e to the x, you'll obtain the same result, which is e to the x. Alright, now if you sub 0 into this function, what will you get? Again, you'll obtain 1. Alright, so e to the power of 0 is 1. Now I want to do the final iteration for the sake of this video. So I want to find the second differential of f of x. Alright, and again, if we differentiate e to the x, we'll obtain the same e to the x. If we sub 0 in this thing, again, we'll obtain 1. Alright, so what we want to do now is to see how we can plug in these results into the Maclaurin series formula. Alright, so recall the Maclaurin series formula. F of x is equal to f of 0 over 0 factorial plus x times the result that we get when we plug in 0 into the first differential of f of x over 1 factorial plus x squared times the result that we'll get when we plug in 0 into the second differential of f of x over 2 factorial. All right, and again we can continue this thing go on and on. All right, so we'll stop right there for the sake of this video. Now we're going to plug in these values now. So f of x is equal to, now what did we get for f of 0? The result that we got was 1 over 0 factorial, which is 1. So 1 over 1 is 1, all right? Then we have what? X times the result that we got when we substitute 0 in the first differential of f of x, and that was 1 also. So 1 times x, that will remain x over 1 factorial, which is 1. So x over 1 is the same thing as x plus x squared times the result that we got when we sub 0 into the second differential of f of x, and that result was 1 also. So we'll have 1 times x squared over 2 factorial, and then 2 factorial is 2, all right? And this thing will continue. So this will be our answer or our solution for this particular question, all right? So this is how we would write Maclaurin series expansion for the f of x function that was given in this particular question, all right? So f of x is equal to e to the x, all right? So this would be the how you write Maclaurin series expansion for this particular function, all right? Now let's look at another example. What if we had f of x is equal to cos x, all right? So again, we want to find the things that we want to find. We're going to outline here. We want to find f of 0. We want to find the result that we'll obtain when we sub 0 into the first differential of f of x. And we also want to find the result that we'll obtain when we sub 0 into the second differential of f of x, all right? And again, I'm only going to do 3 iterations, so we can get through this video in a timely manner, all right? So this will give you a basic idea, even if you're required to carry out more iterations, all right? So we want to find our f of 0. So f of 0. Now, if you should substitute 0 in this thing, cos of 0 is actually 1. So if you use your calculator, cos of 0, that result that you will obtain would be 1. Now, I want to substitute 0 into the first differential of f of x. So we are required to find the first differential of f of x. So I want to find the first differential of f of x. If we should differentiate cos x, we'll obtain negative sine x. All right. So if we should substitute now 0 into this function, what would we obtain? All right. Sine of 0 is 0. Negative 0 is the same thing as 0. So the first differential, if we substitute 0 into the first differential, we'll obtain 0 as our result. All right. Now we want to obtain the result that we'll get if we substitute 0 in the second differential of f of x. So the second differential of f of x, we are required now to differentiate the first differential to obtain the second differential. So if we differentiate sine, so we can factor out this negative right here. If we differentiate sine x, we'll obtain cos x. All right. So this thing is the same thing as negative cos x. All right. And if we should substitute 0 into this function that would have obtained, and again, cos of 0 is 1, and we have a negative there, so we'll have negative cos of 0, so that will give us negative 1. So we'll obtain negative 1 there. So the result that we would have obtained as it relates to this thing would have been negative 1. So if we substitute 0 into the second differential of f of x, then we'll obtain negative 1. Now, we want to recall the Maclaurin series formula where f of x is equal to f of 0 over 0 factorial plus x times the result that we get when we substitute 0 into the first differential of f of x over 1 factorial plus x squared times the result that we'll get when we substitute 0 into the second differential of f of x, all right, over 2 factorial. And again, we can do many iterations of this thing, all right? So how do we plug in these values now? Again, we do the same thing as the previous example. So we have our f of x. What was the value that we got for f of 0? Our f of 0 was 1, so we have 1 over 0 factorial, which is 1. So 1 over 1 is 1 again. Now we'll have what? X times the result that we got when we substitute 0 into the first differential of f of x. And that result was 0. So 0 times x, that's the same thing as 0, all right? All right, so we don't even need to look at this 1 factorial here. So that will end up with 0 over 1, all right? And 0 divided by anything is 0. What will we obtain now? So we have what? X squared times the result that we'll get when we differentiate, when we sub 0 into the second differential of f of x. And when we did that, we got negative 1. So we'll obtain negative x squared over 2 factorial, which is 2, all right? And we can write this in a simpler form. So in this case, f of x is equal to 1. This positive and a negative sign will give me a negative. So this is 1 minus x squared over 2. Now let's look at how we can write Maclaurin series expansion for this particular function. F of x is equal to ln of 1 plus x, all right? So again, we know that we are going to need what? We are going to need the result f of 0. We're also going to need the result that we'll obtain if we sub 0 into the first differential of f of x. And we're also going to need the result that we'll obtain if we sub 0 into the second differential of f of x, all right? So let's first find our f of 0. Now, if we should substitute 0 in this function right here, we'll end up with ln 1, all right? Because 1 plus 0 is 1, so ln of 1 will give us a 0 right there. And you can always test these results in your calculator, all right? You can always check that out. So now we want to find what? In order to substitute 0 in the first differential of f of x, we must first know the first differential of f of x, all right? So if we differentiate an ln function, what ln of whatever, will differentiate that. So we have ln of 1 plus x, we'll differentiate the 1 plus x, and that will give us a 1. Then we'll put that result over the function itself, all right? So that's how you treat with the differential of an ln function. So this will give us, the first differential will give us 1 over 1 plus x. If we should substitute 0 in this thing, what will we get? All right, 1 over 1 plus 0. This will give us 1, so we'll have 1 over 1, and that's 1, all right? And the final iteration, for the sake of this video, we'll find the second differential of this thing. Now, what we could do, all right, we can rewrite this function, all right? So first differential of x can also be written as, we can bring up the denominator up. So we can bring this thing up in the top, and it will become 1 plus x to the power of negative 1, all right? So that's the same thing, so we can do that. So this is easier to differentiate. Of course, we could differentiate this thing using the quotient rule, but I guess you choose how you want to do it, all right? But I prefer to do it like this. However, anyways, work anyhow. All right, so we're going to use a chain rule to differentiate this thing. So we're going to multiply the bracket by the power. So we have negative 1 times what we have in the bracket, 1 plus x. Then we'll minus 1 from the power. We'll have negative 2. Then we'll multiply this thing by the differential of the bracket, which is 1. All right, so this is the same thing as negative 1 times the bracket, which is 1 plus x to the power of negative 2, all right? Because 1 times anything don't change the value of the thing. We can also rewrite this thing as -1. We can bring this bracket down in the denominator. It's the same thing as 1 plus x in bracket raised to the power of 2. Alright? So we can do that. Now I want to find what the result that we'll obtain when we sub 0 into the second derivative, which is -1 over 1 plus x all squared. Alright? So if we should substitute 0 in this thing, we'll get 1 plus 0. So we'll only be left with 1 in the bracket. 1 squared is 1. So we'll end up with -1 over 1, which is -1. Alright? So what we want to do now is to plug in these values into the Maclaurin series formula. Alright? So recall the formula. Again, the formula is what? F of x is equal to f of 0 over 0 factorial plus x times the first differential, the result that we'll get when we substitute 0 into the first differential of f of x over 1 factorial plus x squared times the result that we'll obtain when we sub 0 into the second differential of f of x, alright, over 2 factorial. And again, this thing continues. Can have many iterations of this thing. Alright, so we're going to plug in the values that we got now. So f of x is equal to, what was our f of 0? Well, f of 0 was actually 0. Alright, so we'll have 0 over 1. So 0 divided by anything is 0. So we don't need to, so right here, in fact, we can write it. So we'll have 0 plus, let's see what we'll have here. No, what was the result that we got when we substitute 0 into the first differential of f of x? That was 1. So we can have x times 1 here, which is x over 1 factorial. So x over 1 is the same thing as x plus, and here now the result that we got when we substitute 0 into the second differential was what? -1. Alright, so we'll have negative x squared over 2 factorial, which is 2. Alright, and again, we could have had more iterations of this thing. So that's where we'll stop. So f of x is equal to, don't have to rewrite that 0, so x, again, have a positive and a negative, we get a negative result. So x minus x squared over 2. And we could have had more iterations of this thing. Alright, so this would be the result for this particular function. So this is how we would write Maclaurin series expansion for this particular function. And here we have the final example that we'll be looking at today. So we are going to look at how we write Maclaurin series expansion for the function f of x is equal to 1 plus x all raised to the power of a half. Alright, so how do we do this? Again, we need to find our what? We know that we need to find f of 0. We need to obtain the result that we'll get when we substitute 0 into the first differential of f of x. We also want to know the result that we'll obtain when we substitute 0 into the second differential of f of x. And again, always bear in mind that you can have more iterations of this thing, alright? So if we wanted to do one more iteration, we'll also be required to find the result that we'll get when we substitute 0 into the third differential of f of x, alright? So always bear that in mind. So this is the final example in this video, alright? Now let's obtain the values that we need. So f of 0, if we should substitute, so a key thing to note is that f of x here, f of x is equal to, this is the same thing as 1 plus x raised to the power of a half is the same thing as the square root of this entire thing right here. Alright, so always bear that in mind. So f of 0, if we should substitute 0 here, we'll have 1 plus 0, the square root of 1 is 1, so f of 0 is 1, alright? Now I want to find what? F, the result that we obtain when we substitute 0 into the first differential of f of x, alright? So I want to find the first differential of f of x. And what is that? if we should differentiate this thing, we can differentiate this thing using the chain rule. What would we obtain? We'll multiply the function by the power. So we have a half times 1 plus x. We'll minus 1 from the power, so we'll end up with negative a half. And we'll multiply that by the differential of the bracket, which is 1. All right. So this is the same thing as, let's see, a half times, we'll have here now, let me see, we can rewrite 1 plus x to the power of negative a half as what? 1 over the square root of 1 plus x. All right. So this is the same thing as 1 over 2 times the square root of 1 plus x out here. All right. So we can do that. Now, if we should substitute 0 into this function that we got for the first derivative, we'll end up with 1 plus 0. So 1 plus 0 is 1. The square root of 1 is 1. 2 times 1 is 2. So we'll end up with 1 over 2. All right. So this will give us 1 over 2. And now we want to find the second differential of f of x. All right. So what do we get if we differentiate this thing that we got? So we can rewrite this thing. So so we want to obtain the function for this thing, but we can rewrite the function for the first differential of f of x. And again, this thing is the same thing as what? 1 over 2. In bracket, we have 1 plus x raised to the power of negative a half. All right. Same thing as we had right here, that we had right here. So this is the same thing as that. Now, if we should differentiate this thing, all right, and I'm going to come down a little bit. So if we should differentiate this thing, the second derivative, what we'll obtain is that we'll multiply this thing by the power again. So negative a half times this entire thing will obtain what? Negative 1 over 4. In bracket, we have 1 plus x minus 1 from the power. We'll get negative 3 over 2. And then we'll multiply this thing by the differential of the bracket, which is 1. All right. So we differentiate this thing using the chain rule. All right. So, and again, we can rewrite this thing. So negative 1 over 4, this is the same thing as negative 1 over 4 times 1 over the square root of 1 plus x, all raised to the power of 3. All right. So we can do that, and we can clean it up a little bit. So can clean this up some more. So this is the same thing as negative 1 over 4 times 1 plus the square root of 1 plus x raised to the power of 3. All right. So where do we go from here now? Well, we want to find what we get if we substitute 0 into this function. And that will give us negative 1 over, let's see. If we should substitute 0 into this thing, what would we get? 1 plus 0, that's 1. If 1 cube is 1, 4 times 1 is 1, so we'll end up with 4 times 1, which is 4. All right, so this is the same thing as negative 4 over 4. All right, so that's what we'll obtain. So now we want to, final step is to write this thing using the Maclaurin Series expansion formula. So we'll have, call the formula f of 0 over 0 factorial plus x times the result that we get when we sub 0 into the first differential of f of x over 1 factorial plus x squared times the result that we get when we sub 0 into the second differential of f of x over 2 factorial. And as always, we can always continue that thing. All right. So what we want to do now is to plug in the values that we got. So f of x will be equal to, what did we got for f of 0? our f of 0 was 1. So we got 1 right there. So we can have 1 over 0 factorial, which is 1. So that's 1 over 1. So we can have 1 right here. What did we get for our, when we substitute 0 into the first differential, we got 1 over 2. So we'll have 1 over 2 times x over 1 factorial, which is 1. So all of this plus the result that we got when we substitute 0 into the second differential of f of x, and that was negative 1 over 4, and we multiply that by x squared over 2 factorial, which is 2. All right. So this will give me f of x being equal to 1 plus, this is the same thing as x, so 1 plus x over 2. All right, and this is minus x squared over 8. All right, so and again we could do more iterations of that. So that's pretty much how you use the Maclaurin series, all right, to expand a function. So hopefully this video helped you guys to be better able to understand how to use the Maclaurin series formula. If this video helped you in any way, please consider to subscribe to this channel and hit that notification bell to be notified whenever we post new videos. All right, so thanks for watching.